Hello, I'm Kong Meng. So today we are going to present our mini project for the course DSA. The title of our project is UTM Sport Complex Facility Bookings and Waiting List System. Allow me to introduce my team members. We have Hui Xin, Ling and also Yeoh Khai Jet. Let's begin with the introductions. Our mini project is to design and build an application that digitizes and manages the booking operations for campus sport facilities. To handle this, we apply three core data structures: a singly linked list to store static facility profiles, dynamic vector to manage active student booking smoothly, a custom first in first out quick to organize waiting lines ready when the course is full. The system automates the booking life cycle. The student can check live availability for instant confirmation. If a cot is occupied, the system will queue their request. The moment a user checks out, the system automatically upgrades the next student in line to a confirmed slot. Lastly, admin can generate a report sorted instantly using an insertion sort algorithm. So in brief, these are our three main goals for our project. First, to develop an automated user-friendly digital system that replaces the manual paper-based tracking methods currently used in the UTM Sport Complex. Second, to demonstrate how proper memory allocation, node manipulations, and quick logic can smoothly manage real-time data changes, such as upgrading a waiting student to a confirmed slot the moment a course is released. Third, to deliver robust data organization and reporting features for sport complex administration. Now let us focus on the use case diagram. The use case diagram serves as the functional blueprint for our sport complex application. The main user of our applications are the students and the admin. Our system requirements explicitly separate tasks between them. The student is permitted to view facility status, book a course, and check up to release an active slot, while the admins, on the other hand, hold administrative right to generate multi-criteria sorted reports and inspect the waiting list quiz. Thank you.
Okay, thank you, Kong Meng. So now I will walk you through the technical backbone of our system. So everything from our system runs on three core C++ data structure and with one main application level. So each one of these is solve a different problem. So the first one is the linked list. So we will use the singly linked list on our master facility catalog. So each chord, field, and the pool is a node that points to the next one. We chose it because the facility list is read in order and we can add a new chord just by attaching a node without resizing anything. The second one is a dynamic vector, which we use it for the active confirmed booking. Bookings are added and removed all the time. So a vector is ideal because it grows and shrinks freely with no size limit. The third one we use is the FIFO queue for the waiting list, so that a student who has waited the longest for a chord is served first. So let me show you how all of this is connected. Okay, this masterclass diagram ties everything together. It also maps out the four modules that we built. On the left is the facility module, where the facility list class owns a chain of facility nodes. The diamond means composition, so the list contents is not. On the right hand side, where you can see is the booking waiting list module, built the same way, where the waiting list queue class holds a chain of queue node objects through its front and rear pointers. The important link is here because each of the queue node carries one booking, so a booking student's full detail move through the queue with them. At the center here, you can see is the active booking vector, and that fits into the sorting module, where our sorting class runs the sorting using the insertion sort to generate the reports. And tying all of this together is the main application module, which handles the menu and call each of the module based on what the users pick. So the booking record is really the common thread. It sits in the middle in the queue while waiting and move into the vector once it's confirmed. As you can see, this is the flowchart for the waiting list module. This module is one of the three core functions that is developed in our project. So from the main menu, the user picks one of these three applications, and then each one of the module will follow on its own path. Let me start with the end queue. On the right, which runs when the code is full and the student joins the queue. The system first checks if the queue is empty. So if it is empty at the very first entry, it sets both the front and the rear pointer to this new node. If it is not empty, it attaches the new node to the rear and up that's the rear pointer. So either way, the students end up at the back of the line. This is what that is keep it first in, first out. Next is the DQ in the middle, which runs when the slot opens up. The system checks if the front node match the requested chord. If it does, it simply moves the front pointer forward and return that student. If it does not, however, it walks through the queue to find the first match for that chord, then bypass that node and feeds the neighboring pointers. Last is the show list on the left, which you can just walk through the nodes and print everyone waiting for the chord, or tell you when the list is empty. That automatic promotion when the chord frees up is our main waiting list module. Thank you.
Hi Dr. Pang, my name is Hui Xin. I'm going to present the sorting module. This flowchart shows the insertion sort algorithm used to organize booking record. The system read the book record, select the current booking as the key, compare it with the previously sorted record, shift larger record to the right, and insert the key into the correct position. This process repeats until all booking records are sorted. The same algorithm is reused to sort record by booking ID, user ID, facility name, booking date, start time, and priority score. Before facility can be displayed, that must first be stored in the system. The add facility functions receive the facility details, create a new link list node, and insert it into the link list. If the list is empty, the new node becomes the head node, otherwise it is added to the end of the list. The search facility function retrieves facility information from the linked list. The system starts from the head node, compare each facility name with the target, and return the matching facility if found. Otherwise, it continues searching until the end of the list and displays not found if no match exists.
Hi, a very good day to Dr. Pang. I am Yeoh Khai Jet, and I will be explaining the operational workflow of our UTM Sports Complex Facility Booking System as mapped out in this flowchart. So when the application boots up, it begins by loading the default system data into dynamic memory, including the facilities details and mock bookings. It then represents a centralized main menu with 5 clear options. This menu operates within a strict control loop. So if a user enters an invalid number, the system catches the error and safely routes them right back to the main menu page. So now let's look at what happens when a valid path is chosen. So when the user chooses option 1, it will take the user to the view module to check real-time facility status and also generate the sorted booking reports. So if the user chose option 2, it will launches the booking menu. After gathering the user's booking details, the system runs an availability check to check if the course is available. The booking is instantly confirmed. If it is full, the request is automatically pushed into our waiting list queue. Then if the user choose option 3, it will take the user to the checkout module. So when an active booking is removed, the system immediately checks if anyone is on the waiting list for that specific facility. If yes, it seamlessly assigns the code to the next waiting user. And if the user chooses option 4, it will direct the user to the queue view module to view their current queue and check who is currently in the waiting list. If the user chooses option 5, it will exit the system and safely closing out all the operations. This architecture ensures a highly efficient, fair, and fully automated booking ecosystem for our sports center complex.
This is the main menu of our system. It provides users with 5 main functions, including viewing facility status, booking a facility, releasing a booking, viewing the waiting list, and exiting the system. Users simply enter the corresponding menu option to access the required function. This screen displays the facility status and booking report. The upper section shows information for each sport facility, including his ID, name, type, maximum capacity, booking mode, and current availability. The lower section provides the sorting menu, where administrators can choose different sorting criteria such as booking ID, user ID, facility name, booking date, slot time, or priority score. After a sorting option is selected, the system executes the insertion sort algorithm and displays the sorted booking record, making booking information easier to monitor and manage.
Next, I want to highlight the core operational capabilities of our system's main workflow engine, which acts as a powerful dual-function gateway by centralizing both facility booking and reservation checkouts within a single user interface. To protect the data integrity, the system completely eliminates manual text entry typos by displaying a fixed numbered selection menu for all 11 complex facilities. Once a facility is chosen, it initiates a step-by-step data capture process, smoothly guiding your user to input their memory ID, name, date, slot time, and also the priority scores. Behind the scenes, the system features an intelligent real-time routing. It instantly evaluates the facility constraints to either issue a success confirmation or route the user request to the waiting list if the code is full. Finally, when a code is released, our system triggers a facility-specific DQ, instantly promote the longest waiting student for that exact facility to confirm status. Next, I would like to walk you through the waiting list queue display of our system, which is designed to give administrators complete transparency over the court slots availability. It is accessible via the main menu option 4. With this module, it serves as a targeted backlog inspection tool. To ensure a consistent input safety, it utilizes the exact same error-free number selection list from 1 to 11, completely removing the risk of manually typing mistakes when selecting the code. Once a facility is selected, the system performs a chronological queue traversal. It checks the front pointer and loops sequentially through the linked queue pointers all the way to the rail, filtering the data by the targeted facility name. By printing out the precise waiting position, numeric ID, and student name in the exact chronological order of their arrival, this gives the administrators a granular visibility. Ultimately, this allows for real-time next in-line tracking and providing a full operational transparency so that the administrators always know exactly which student is next to be promoted the moment the slot is open up. Okay, so now we're presenting our demo session for our UTM Sports Complex Facility Booking and Waiting List System. So by pressing 1, we can get into our booking list and so for here I press 3 to get our booking list in the alphabetical order. So we can see that in the booking list there are 4 bookings currently from Yeoh Khai Jet and Badminton Court 1, the Kong Meng Badminton Court 1, but they're different date. Yeoh Khai Jet on a basketball field and Ling on the swimming pool. So if we want to do a booking, we can press 2 to get a booking code, the field, and to enter the booking facility code and field module, and then we can choose our facility that we want. Let's say we want badminton code 1, press 1, and then we enter our user ID, then we enter our username, let's say John Lim. Next, we will need to enter the date. Let's say we use the same date as the booking from Yeoh Khai Jet, for is 24th of June and 10:30. Okay, so next we need to put our priority, let's say the same priority 5. So when you see that the code is being booked, so we enter the queue. So when we choose, when we check the view for the waiting list, we can see that we are entered the waiting list by pressing the 4. Then next, if we check back the waiting list, the booking facility, you can see that we are not entered the booking list. So as we are in the waiting list. So next one we can, so let's say we release the third by pressing 3, and then we release the code 1, then we can see that Yeoh Khai Jet has been removed and is replaced by the waiting list John Lim. So when we check back to the booking list, you can see that John Lim has entered into the booking list. And when we check the waiting list, you can see that John Lim has been removed from the waiting list and entered to the as he have entered to the booking list. That's all for me of our demo. Thank you. Okay, so now we're presenting our demo session for our UTM Sports Complex Facility Booking and Waiting List System. So by
Thank you, Jet. To conclude our presentation, let us review our key takeaways. We successfully built a fully integrated crash-resistant console prototype for campus sport facility. Our system cleanly combines 3 core data structure: linked list for facility data, vectors for active bookings, and first-in, first-upgrade for waiting list. This setup enables automated logic that instantly upgrade the next student in line the moment the code is released. Looking ahead, our planned future enhancement include transition this text console into a visual graphic user interface and connecting permanent file storage to save booking logs after the application closes. That brings our presentation to an end. Thank you very much for your time and see you again. Bye bye.